Here are the answers to the worksheet that you just completed. So if you want to take a minute to pause the video and read through what I wrote, but I talked about first expanding on the first one. After I expanded it, I could then use the power rule once I got it as a polynomial. And then I went through showing how do I do a composite function. So I do have all my steps down. And then on the third one, that's the one I kind of want to spend a little bit of time on, decomposing a composite function. So notice I said that when I look at the function that I'm given, I asked myself what function could have been plugged in. Well, to me it looks like I could have plugged an x minus 3 in. If I plugged an x minus 3 in, what would I have plugged it into? I would have plugged the x minus 3 into the radical and then still had a plus 4 on the outside, which led me to believe that my inside function, say my g of x, my inner function would be x minus 3, and my outside function that I plugged x minus 3 into would have been the square root of x plus 4. So the reason why we look at that is because we're going to move into a topic called the chain rule. The chain rule shows us how we can differentiate when we have an inside function and an outside function. So, for example, on this first one, there is a way to differentiate this or to find the derivative of this without writing it out and expanding it. So, this is the process we're going to use. As I said just a moment ago, it's called the chain rule. The book, the way they describe the chain rule is to say that what we're going to do is we're going to differentiate the outside function, leaving the inside function in, then multiply that by the derivative of the inside function. I do the same thing, but I like to be able to keep my work a little bit neater. So I use another form of that rule that the book gives you. I say that I'm going to label my inside function as u, and I'm going to label my outside function as v. And then what I'll do is I'll take v prime of u times u prime. Notice they're the exact same thing. The only difference is I have v in place of my f, and I have u in place of my g. I just think it looks less confusing without the of x's. So I'm going to go ahead and go over, I have 4 examples. I am going to go ahead and use this form of the rule. The reason is because this form is in your book, so if you do not like the way I'm doing it, I strongly suggest that you open up your book to section 2.4 and look at how they're using this form of the formula here. So on the first one, first thing I'm going to do is I'm going to label my inside function u. Well, I can see that my inside function is x minus 3, and I'm going to label my outside function 2u cubed. Okay? So now from here, according to my rule, it looks like I'm going to need to find the derivative of both my outside and my inside function. So the derivative of my inside function, which I'm calling u, would be just 1. The derivative of my outside function would be 6u squared. So now according to my rule, my overall derivative for example 1 should be v prime of u, so v prime with u plugged back in, times u prime. Well, that gives me 6u squared times 1. But because my original function was in terms of x's, I want my new function to be in terms of x's as well. So all that means is I'm going to take that u and put x minus 3 back in place for it, giving me a final answer of y prime equals 6 times x minus 3 squared, because I do not have to write the times 1. Let's look at some more examples. On example 2, I'm going to do the same thing. I'm going to go ahead and I'm going to label my inside function and I'm going to label my outside function. I'm going to call my inside function 2 minus 9x, and my outside function is then negative 3u. Well, I was going to do it in one step, I'll do it in 2 since it's the first time we've seen it. Negative 3 times the 4th root of u. Now remembering my rule, or looking up above at my rule, I need both u prime and v prime to get the final answer. So if I take the derivative of my inside function, u prime is negative 9 since the 2 goes away since it's a constant. V prime, well in order to find v prime, I'm going to first rewrite v as negative 3u to the 1/4. Therefore, v prime will be negative 3/4 u to the negative 3/4. And so now that I know u prime and v prime, according to my formula, I can say that my derivative is equal to u prime times v prime, or v prime times u prime, however you want to look at it. So I'll have negative 9 times negative 3 over 4 u to the negative 3/4. Well, now all I have to do now that I have it written out is do a little bit of simplifying. I can multiply these, and I also have to plug u back in because I want my final answer to be in terms of the same variable as my original problem, giving me f prime of x equals 27 over 4 times 2 minus 9x to the negative 3/4. Notice I could also move this to the bottom and make it to the positive 3/4. I could also move this to the bottom, making it to the positive 3 and put it underneath the fourth root. So I have a lot of algebraic moves I could still make. So just something to be aware of, especially when checking your answer in the back of the book. If I look at number 3, first thing I'm going to notice is this is the same thing as y equals cosine of 9x squared. And now remember, trigonometric functions, we use trig functions to, we take a trig function of our inside function. So I'm taking cosine of this inner function. So for that reason, my inside function is going to be 9x squared. My outside function is going to be cosine of, and I should say of u to stay consistent, so cosine of u. Then my derivative of my outside function is 18x. The derivative of, or excuse me, of my inside function, the derivative of my outside function is negative sine u. So my overall derivative is u prime times v prime, 18x times negative sine u. Again, I do have to make sure and plug 9x squared back in for u. And I'm going to go ahead and multiply these together, which is really just going to mean I'm going to pull my negative out front so it doesn't look like I'm using a subtract, giving me y prime equals negative 18x sine of 9x squared. And I'm going to put parentheses around that so it's clear that I'm taking the sine of that entire thing. Looking at one final example, this would be a good one for you to pause the video on and try on your own. All right, now that you've had a chance to try one, I'm going to go ahead and I'm going to say that my inside function, if I first try it, I would probably say my inside function was 9t plus 2 squared, and my outside function was the cube root. That's fine. And then I could square u. I want to make note, and I'll just do it this way. I could also, because I'm going to assume that those of you who tried it on your own, that was probably the way you went. I could also say that u is 9t plus 2, and v is u to the 2/3. So either way will work. I'm going to go ahead and work it the first way. So then I can say then that u is 81t squared plus 36t plus 4. Therefore, u prime is 81 times 2, so 162t plus 36. My constant goes away. So rewriting v is u to the 1/3, therefore v prime is 1/3 u to the negative 2/3. And my overall f prime of t is u prime times v prime. But again, I'm going to replace u, and I'm going to replace it with 9t plus 2 squared. And then that all gets raised to the negative 2/3. I am going to use some algebra to clean this up a little bit. Mainly what I want to do is I want to multiply my exponents to begin with. So I'm going to say 162t plus 36. I'm going to put, this is all being multiplied, so I'm going to put the 3 on the bottom, because dividing by 3 is the same thing as multiplying by 1/3, times 9t plus 2 to the negative 4/3, because I multiply my 2's here. And then I could also, if I wanted to, bring this to the bottom, which I think I will, just to make it look a little bit nicer. And I get 162t plus 36 all over 3 times 9t plus 2 raised to the positive 4/3. Looking further, I could also, if I wanted to, reduce all of these by 3. So 162 divided by 3 is 54. So I can say 54t plus 12 all over 9t plus 2 raised to the 4/3. And that is my chain rule. Once again, if you do not like the U's and V's, also remember that your book is going to show you a slightly different method for doing it, or a slightly different way of thinking of it. They do give you the same result, because it really is the same. It's just how do you want to refer to your inside function, your outside function? Do you want to refer to them as f of x and g of x, or do you want to refer to them as u and v? And I would use, one of the other reasons I don't use f and g is just because sometimes you'll have to do the chain rule with the product rule.